Okay, so let's talk about determining valence electrons. Now, valence electrons are the electrons at the outermost energy level, not sublevel, energy level. So if we look at this first example here, I've got the orbital diagrams. We see that we've got the first energy level represented. We've got electrons there. We got electrons in the second. We got a lot of electrons in the third. We got 3s, 3p, and 3d. And we have electrons in the fourth. This is what you're looking for. You're looking for the biggest number. Now you look and see there's 4s, you look over here and say, is there 4p? And the answer is no, so you can just count p0. Technically, you would always be adding the s's and the p's together. D's are always going to be buried. If you're counting d's, you're doing something wrong. You never, never, never count d's when you try to figure out valence electrons. Because in order to fill the d's, that means the next energy level, s sublevel, has to be filled. So this has to be filled before you can even get to the D's. This will never be the outermost energy level. The fourth energy will be the outermost. Or if you have 5s, in order to get to 4D, this has got to be filled. 5 is bigger than 4, so this energy level is going to be the one with the electrons, the valence electrons. So in any case, we've got 2 here, we've got 0 there, so there's going to be 2 valence electrons, electrons in the outermost energy level. These are the guys who play the bonding game. Look at this one. We got electrons in the first, electrons in the second, a lot of electrons, 8 of them in the second. And now we've got 1, 2, 3, 4, 5, 6 electrons in the third energy level. So these are our valence electrons. These are the guys who are important in bonding. And if you want to check to see if you're doing it right, as long as it ends in the S or the P block, as long as it's not one of those rebels, those D block guys, as long as it's either in the S or the P block of the periodic table, they're going to add up to equal the group number. Remember, we labeled the groups 1, 2, 3 through 8. If you do see a resource that does 1, 2, and then it keeps going 3 through 3, 4, 5, 6, all in the D block, and then by the time you get back up to group 3, it's 13, 14, 15, 16, 17, 18. If you see 1 through 18, then just ignore the 10 spot. Cross off the 1, and this is your valence electrons, 3, 4, 5, 6, 7, 8. So over here, I know I got 6 valence electrons. That means this element is going to end in group 6. 1, 2, 3, 4, 5, 6. And it's going to be in the third period, or the third row of the periodic table. And that is going to end up being 1, 2, 3, 4, 5, 6, sulfur. So this is sulfur. Okay. All right, let's take a look at electron configuration and figure out how many valence electrons we have. So again, we've got first energy level, second energy level's got electrons, third energy level has electrons, and the fourth energy level has electrons. Which energy level is the highest? Energy level is 4. Now I have 2 sublevels filled, so I add them both together. Add S's and P's. 2, 5, that's 7. So this element's going to have 7 electrons that are dealing with the bonding. It's got a lot of other electrons, but we're only going to worry about the 7 when it comes to bonding. And if I want to know what element this is, I look in the 4th row in the P5 column, and that would give me bromine. And bromine is in group 7. Or if you're looking at the 1 through 18 method, it's in group 17. Okay, just look at that last number, and that should match valence electrons. All right, let's look at this last crazy one here. We got electrons in the first, in the second, in the third, in the fourth. Look at the fourth. We've even got them all the way out here in the fourth, 4F14. And we've got electrons in the fifth, 5s, 5p, 5d, and we have electrons in 6. This is our winner. 6 is greater than any of those numbers. It doesn't matter that we fill 4f after 6s. It doesn't matter that we fill 5d after 6s. 6s is just a part of that 6th energy level. We also theoretically have the p with 0, the d with 0, and the F with 0, but it could hold up to 14. So the 6th energy level is bigger than the 5th energy level. It's further away from the nucleus. So overall, there are 2 valence electrons here. These are the ones involved in the bonding.